Vector Database Guide Introduction. A vector database is a specialized database designed to store, search, and retrieve vector embeddings efficiently. Vector databases are widely used in AI applications, semantic search, recommendation systems, retrieval augmented generation, RAG, image similarity search, chatbot systems, large language model, LLM applications. A common interview topic is, what is a vector database and how does it work? This guide explains. Check. Vector embeddings, vector similarity search, indexing, ANN search, RAG architecture, popular vector databases, real-world system design, scalability, optimization, common mistakes, best practices. This is one of the most important topics in modern AI engineering and machine learning systems. Simple definition. A vector database is a database optimized for storing and searching high-dimensional vector embeddings using similarity search algorithms. Why vector databases exist? Traditional databases search exact values. Example: select star from products where name equals laptop. But AI applications require semantic similarity search. Example: best budget gaming computer should also match gaming laptop, affordable PC, entry-level gaming system. Traditional SQL databases struggle with this efficiently. What is a vector? A vector is a numerical representation of data. Example text. Artificial intelligence embedding model converts it into 0.12, negative 0.88, 0.45, 0.91. These numbers represent semantic meaning. What can be converted into vectors? Many data types can become vectors. Examples. Data type example: text, documents, images, photos, audio, voice, video embeddings, products, recommendation data, vector database workflow. Typical flow: raw data, embedding model, vector embeddings, vector database, similarity search. What are embeddings? Embeddings are dense numerical representations generated by AI models. Popular embedding models. Check. OpenAI embeddings. Check. Sentence transformers. Check. BERT. Cohere embeddings. Check. Vertex AI embeddings. Example: dog and puppy. Generate similar vectors. Similarity search. Vector databases search for nearest matching vectors. Unlike SQL equality matching, common similarity metrics. Metric purpose: cosine similarity, semantic similarity. Euclidean distance, spatial distance, dot product, embedding comparison, cosine similarity. Very common interview topic. Measures: angle, similarity between vectors. Higher similarity, closer semantic meaning. Exact search versus approximate search. Checks every vector. Benefits: highly accurate. Problem: no. Slow from massive datasets. Approximate nearest neighbor, ANN. Most vector databases use ANN algorithms. Benefits: check extremely fast. Check scalable, near accurate results. Popular AN algorithms. Check HNSW. Check IVF. Check PQ. Check scanin. HNSW. Hierarchical navigable small world. Very common ANN indexing method. Benefits: cast retrieval. Cast scalable similarity search. Cast high recall accuracy. Used by check Pinecone. Check Weaviate. Check Cridgrant. Popular vector databases. Database description: Pinecone, managed vector DB. Weaviate, open source AI native DB. Cridgrant, high performance vector search. Milvus, large scale vector database. Chroma, lightweight vector DB. Elasticsearch, hybrid vector search. pgvector, PostgreSQL vector extension. Vector database architecture. Typical architecture: application, embedding model, vector database, Similarity results. Example. Semantic search. User query. Best backend framework for Java. Flow. Query embedding generated. Vector search. Similar documents returned. Results may include CAPS Spring Boot, CAPS Micronaut, CAPS Quarkus. Even if exact words differ, metadata filtering. Vector databases often support metadata. Example. Category, technology, language, English. Benefits, hybrid filtering, improved precision. Hybrid search combines vector similarity, keyword search, architecture. Keyword search plus vector similarity, better search results. Used in enterprise search, e-commerce, AI chat systems, retrieval augmented generation, RAG. Very important modern AI architecture. RAG combines vector search, LLMs, RAG, workflow, user query, embedding model, vector search, relevant documents, LLM prompt, generated response. Why RAG is important. Benefits. Check. Reduces hallucinations, provides fresh data, supports private knowledge bases, improves LLM accuracy. Chunking strategy. Documents are split into chunks. Example. Large PDF, small text chunks. Embeddings. Best practice. Chunk by semantic meaning. Chunk. Avoid overly large chunks. Embedding dimensions. Vectors have dimensions. Examples. Model dimensions. OpenAI text embedding 3 small. 1536, Mini LM 384, BERT 768. Higher dimensions. Richer representation. More storage cost. Real-world use cases. 1. AI chatbots. Flow. User question, vector search, relevant knowledge, LLM response to, recommendation systems. Examples. Netflix recommendations, Amazon products, Spotify music suggestions. 3. Semantic search. Search based on meaning, instead of exact words. 4. Image similarity search. Find visually similar images. 5. Fraud detection. Detect unusual behavioral similarity patterns. Vector database with Spring Boot. Typical architecture. Spring Boot API, embedding service, vector database, LLM search results example, using PG vector. PostgreSQL extension. Create extension, vector, table example. Create table documents. ID serial primary key. Embedding vector 1536. Similarity search. Select from documents. Order by embedding point 1, point 2, point 0, limit 5. Performance optimization. Important optimization areas. ANN indexing, caching, batching embeddings, metadata filtering, GPU acceleration. Scaling vector databases. Large-scale systems require C distributed storage, C sharding, C replication, C optimized indexing. Architecture. Users, API layer, embedding service, distributed vector DB cluster, security best practices. Important areas. TIC access control, TIC API authentication, TIC encrypted storage, TIC tenant isolation. Common challenges. 1. Poor embeddings. Bad embedding quality reduces accuracy. 2. Wrong chunk sizes. Too small. X. Loses context. Too large. Noisy retrieval. 3. No metadata filtering. Reduces precision. 4. Expensive embedding generation. Embedding APIs may become costly. 5. Vector drift. Embeddings become outdated over time. Common beginner mistakes. 1. Treating vector DB like SQL database. Similarity search works differently. 2. Ignoring ANN indexes. Performance becomes slow. 3. Storing huge raw documents. Use chunking instead. 4. Not caching embeddings. Repeated embedding generation wastes resources. 5. Using wrong embedding model. Model should match use case. Best practices. Choose proper embedding models. Use semantic chunking. Combine metadata filtering. Use ANN indexing. Cache embeddings. Monitor retrieval quality. Optimize chunk sizes. Use hybrid search when needed. Secure vector APIs. Evaluate recall accuracy regularly. Common interview questions. 1. What is a vector database? A vector database stores and searches vector embeddings efficiently using similarity search algorithms. 2. Why use a vector database instead of SQL? Vector databases support semantic similarity search for AI applications. 3. What is cosine similarity? Cosine similarity measures how similar two vectors are based on angle similarity. 4. What is ANN search? Approximate nearest neighbor search provides fast similarity retrieval for large vector datasets. 5. What is RAG? Retrieval augmented generation combines vector retrieval with LLMs to generate more accurate responses. Example AI search architecture, user query, Spring Boot API, embedding service, Pinecone, Qdrant, Weaviate, relevant documents, LLM response, vector database versus traditional database. Feature, SQL database, vector database. Exact match, excellent, limited. Semantic search, weak, excellent. AI search, difficult, optimized. ANN indexing, no, yes. Embeddings, not native, native. Final summary. Vector databases are foundational for modern AI systems. Important concepts include class embeddings, class semantic similarity, class ANN search, class HNSW indexing, class metadata filtering, class hybrid search, class RAG architecture. Vector databases power AI chatbots, semantic search, recommendation systems, LLM applications, intelligent retrieval systems. Key idea. Vector databases enable AI systems to search by meaning instead of exact keywords, making them essential for modern generative AI and semantic applications.